Hello there and welcome to this workshop or course. My name is Valentine and I'll be your facilitator. In this workshop, we are going to take the structure, so we'll get started learning about the objectives of the session. After that, we'll talk about what those concepts in relation to the topic at hand, that's text-to-speech with Python, what those concepts are, why we would want to perform them. And later, we'll get into a practice session where we'll get to interact with the Python programming language and apply those techniques in an effort to have an outcome that we would desire when it comes to text-to-speech processes. Then towards the very end, we just talk about the next steps. So getting started, by the end of this workshop, we are expected to have achieved these learning objectives. We should be able to understand the fundamentals of text-to-speech. That's TTS technology and also its applications. We should also be able to learn how to implement and customize TTS models using Python. So in the case of not really specifically analyze those models, but use the parameters or set different parameters so that we are able to have a desired output when it comes to using those TTS models. We should also be able to develop the ability to enhance quality and naturalness of synthetic speech through advanced TTS techniques. It just involves being able to use different parameters to our suiting when it comes to working with specific models. So let's get started. So what is text-to-speech? Text-to-speech just is a process that involves converting written text into spoken words using advanced deep learning techniques. So we would end up using what are called models which have been trained on historical data in the format of audio data. So those models would be in a position to take in any text input and give us some audio output. It can be in different formats, whether MP3, WAV, could be ACC, it could be just different audio formats. In many cases where this could be important, organizations might end up solving a problem for many people, and of course that would translate into revenue. So and we'll get into those applications in a few. So generally, text-to-speech models are those applications that are trained on historical audio data, and they are designed to generate natural and human-like speech. And generally, they would produce just output or sounds or audio format that may somewhat not necessarily be indistinguishable from a human voice. But again, they are not perfect. In some instances, you'll sort of hear some sort of robotic nature, or you'll hear the robotic nature of that particular conversion, especially when you use models which have been trained so much on one language, and when it comes to now producing audio for a foreign language, then you might notice some slight difference. But in many cases, especially with the text-to-speech models that we're going to be using, you won't hear much of a difference when it comes to even English. So how do they work? How does a text-to-speech model work? This is just a standard or general approach. There are different ways that models work, but this is one of the ways, the most common ways. Initially, you have some input, and the expected deliverable from that particular process of text-to-speech would be some sort of audio output. So you give this model an input, so the user would provide some text that needs to be converted into speech. The text can come from different applications. It can come from articles, it can come from maybe summaries that you've gotten maybe from articles, it can even come from other AI models. And that text is processed and just to be able to handle, say, punctuation, abbreviation, in an effort to just prepare it for speech generation. So it's prepared in a format that a model can be able to take and be able to process, and as a result give audio output. Once that text has been processed, and in many cases you may not necessarily see this process. Normally you just give it a sentence, but behind the scenes pre-processing is what would happen, preparing that data for a model. input. So once that is done, what would happen behind the scenes, the text again would be converted into phonemes. Phonemes would be just the basic units of sound in speech, which again would help in just accurate pronunciation. So once phoneme conversion has happened, then the model would now take the data itself, the data that has already undergone that process of phoneme conversion. It would take it and it would try to predict some prosody, which prosody just refers to just rhythm, stress, and intonation of speech, given the text that you have given it. And the idea is that the model is able to make speech, just the speech that you would get from the text that you give it, just sound natural. So the idea is that the model would try as much as it can to use the context just from the text that you've provided in an effort to give an output that sounds real, sounds more like real life. You don't want a model just to sound robotic. So it would try as much as it can to be able to give out that, to make some the sound a bit more natural. So it would predict what is called the prosody. Then the phonemes and prosody information from the model would be used then to generate a speech waveform, which would be actually the actual sound signal that represent the spoken words. And that would be now outputted in the form of maybe maybe an MP3 file or .AAC file, etc. So this is just a general overview of how this text-to-speech process happens. If you go a bit more deeper into some of the sections, you'll find just different techniques which different models work. There are many different models that you can get to interact. Just like the way you have large language models, you would end up working with still many models, but our focus for this workshop will be one particular one that is quite popular. In terms of use cases, there are various use cases for text-to-speech models. One is in AI-powered virtual assistants. So if a model that takes text and gives out text, does its own work. So once you have, let's say, some text that you've generated from a large language model, then you can provide verbal responses using now TTS models. You can also use TTS models to help visually impaired individuals be able to get responses maybe from websites or books or other documents. You can also use TTS models to create audiobooks, podcasts, and other spoken content. And a good example of this would be, there's a tool that summarizes. I use it quite a lot. It's called Blinkist. So it summarizes books, and what normally they do, Blinkist is what I'm going to share on the screen. So they normally summarize just books into just key different ideas. This is not a promotion, it's just an idea or a use case for this. So Blinkists, I don't know why they have a flash here. Okay, well, they do, but generally this particular app, what it does is that it summarizes a book into just different ideas. So you can just go through those ideas like 20 minutes, maybe 30 minutes at most. So you get the ideas. You can read through this different summaries that you find there. But again, one might end up using something like a text-to-speech model to be able to read the summaries if you don't want to sit down and listen. Maybe you're on or maybe you're commuting to work, you might want to listen to this. And it's generally also the same case with audiobooks. It's usually something that can be a good application of such a model. So just going back, and another use case might be maybe deploying you might want to use maybe in automated customer service systems when you want to interact with customers. Again, once you get some input from maybe a large language model that will have determined the best sort of maybe response to give to a user, then you can use that output that would be generated and provide that to a customer. And then if a customer maybe wants to provide their response in verbal form, you can now use what are called speech to text models, which again would do the vice versa of what we would be doing. Then towards that would be an application as well. Another application would be maybe in language learning and pronunciation training. Maybe you're trying to learn a new language and you have this model that's trained in specific foreign language, the language that you want to learn. Then you can use it to be able to learn. You could decide maybe to go through maybe a storybook, but you don't know how to pronounce maybe the words correctly. Instead of getting someone else or hiring someone, you can just simply create an application that basically copies the text or that you have highlighted, and it's able to just pronounce to you how exactly you're meant to be pronouncing the words that you want. So then vast use cases, it would be even quite impressive if we were able to come up with like a series of just projects that you can be able to implement using this technology and use what we are going to be learning in this session. But I think maybe that is something for the future. But so that's just a quick bit, maybe just to show you a few other some more information that might be important in this journey when you are undertaking this process of using just different models. So there are different models that you can use to perform text to speech. There's the OpenAI text-to-speech model. There are actually a few models, not just one. The same case with the Google text-to-speech. There are also different models provided by Google, Amazon, Microsoft, and IBM. I don't know why they usually name them by their companies, maybe for just to be seen that they're big names. But generally, each and every of these organizations, they have their own models, which they provide a way of accessing them. Our focus will be using the OpenAI text-to-speech service that would really come in handy when maybe you want to quickly get started. But if you want some extensive use cases, if you have some use cases that probably might require something that OpenAI text-to-speech model doesn't provide, then you can always look into that. So our focus will be on the first set of models, that's OpenAI. And of course, for all these different models, you need to have an OpenAI account that has some credits. I will be demonstrating with mine, but again, in your own case, you can also do the same thing. You can also get an account. Initially, I think they usually give $5 for credits, and it's also good for learning if this is your first time. So consider that as well. So let's get started. So once you have gotten to this particular point, you can go to the description and click on the link that you'll find there. It should take you to a page that looks like this, and download the sample practice. So if you not download, just click on that link. It should take you to this particular page where you get the sample notebook that we can use for this workshop. If you're an Afterwork member, you could always consider using the practice notebook. But if you're not an Afterwork member, you can just use a sample, but consider becoming one. So once you have done that, I'll be using the practice notebook. It has all the challenges. That's the beauty about it, but the sample doesn't have all. So, but you can still follow through. So starting off with the practice notebook, the first thing that you need to do, even with the sample notebook, is to save a copy in Drive. So go to File, then save a copy in Drive. It should save this copy of notebook or the notebook that you have to your Google Drive, and you can use that for learning. Then click on prerequisites, and we are going to import a few things. Either you can just click on connect on the top right, just to connect your notebook to Google servers. So just waiting for that to happen. All right, as that happens, so to get started with OpenAI's text-to-speech models, we need to install the OpenAI library, just as we would for other use cases. If there's even image generation, you can do so much with OpenAI libraries. So yeah, let's do that. Let's install the OpenAI library, and once it has installed, it will tell you it's successful. Then the next thing we need to do is to import these other libraries. So we need to import OS for interacting with the operating system. It will just allow us to be able to save our files locally and be able to download them, not locally on the cloud, just generally, but within the environment where our notebook is located. So we also are going to import IPython display module, and we are going to use it to listen to the audio file that will be generated. And here we just import the OpenAI class that will allow us to interact with the model. So let's run that, the model that we're going to be working with. So let's run that. Once we have done that, the next thing that we need to do is to set our API key. I think we've gone through some workshops on this. I'll provide a link for just being able to set your own API key, the link that takes you to the website where you can be able to do this. I won't go through that process as much, so I'll leave it up to you. So, but here's mine. You won't find this. I will have disabled it. I'll delete it actually. So this is just for learning purposes. All right. Starting off, we are going to be generating audio from text. We are going to just perform just the basic type of conversion. That's generating an audio file, an MP3 audio file. So assuming that we wanted to generate an audio file and we had some text. So our text is what you are seeing here, what I highlighted. So what we would need to do is reference client, the object, the OpenAI object that we've created, and then use the create method and use its parameters to be able to set the model that we want. The model, there are two models that we can use for OpenAI. There's TTS1. These are the ones that are publicly available as of the publication of this stream. And the type of voice that you would want to be able to hear once you have set once you want. So once that process has happened, so what happens is that you have various voice options, which we'll get to learn about. But if you want maybe a male voice, a standard one, you can use Alloy. Then we set our text, and then we run this to be able to create our to generate our speech, which has happened. Now the next thing that we need to do is to use the write to file function to be able to save the response that we've gotten to an MP3 file. So the extension here would determine the type of file that you want. So we save that once that has run, and then we play that MP3 file. We may not necessarily need this line, but we are playing it on Jupyter notebooks in this environment. But if you go on the far right over here, you'll see once I have run this, output.mp3 will be displayed here. So let's run that. So, and you can see now the file has been displayed, and you can download it if you want it, etc. But again, because this is Python, you can always automate this entire process. You can do things with it. So let's do that. So once you have done that, you can then listen to it. I'm not sure whether you'll be able to listen to it, but I'll just play it and add volume. Maybe you might hear something about it, but if I bring my speaker close enough, you might be able to hear it. Yeah, I think it's okay. I think the speaker, this is the closest one. Let's see whether you'll be able to hear it. Here we go.
There lived a young princess who dreamed of exploring the world.
All right, so I think you've probably, you did hear or you did not, I'm not sure, But if you did, then that's it. You can always export this somewhere else, and you can also now use other Python libraries to like do audio editing and incorporate as whatever techniques that you'd want depending on the use case. All right, pause the video and then work on the next challenge. Uncompressed wave audio. So sometimes we might want to format our data, so not an MP3 format that we might want. Maybe we want to have a wave, a wave audio format that works best for our use case. Maybe we might want to have this type of format that's .wav or .wave. That would be normally suitable for low latency applications in many cases, especially with those applications that do not necessarily require a lot of decoding. So yeah, that's with regards to audio, but this is another type of file that you can be able to generate. Just change here. So yeah, and if I run this.
Why was the math book sad? Because it had too many problems.
All right. Well, it's doing okay, but the only problem is that I would have expected it, because this is a joke. It can tell you, why was the math book sad? Because it had too many problems. Like, I don't know. Of course, you wouldn't get this in that particular case, but I think if you I think this is the direction that these models are going towards, like where you can have parameters that even describe exactly how you would want your output to be like. So yeah, so that's just a bit. So you can also see that we have the output WAV format on the far end. All right, pause the video and then work on the challenge. We can also be able to have a lossless audio compression, maybe for persons who are audio enthusiasts. This is also another type of file that they can use. So there's no limitation. So let's run this.
I told my computer I needed a break, and now it won't stop sending me KitKat.
Okay, so you can see that it works. And something else that you'll notice with the code that we are presenting in this workshop, we haven't enclosed it in functions, but ideally, in practical use cases, you can enclose it in functions and also have parameters that pass whatever model that you want and also the voice that you want. This is just for learning purposes. Pause the video and then work on the challenge. Okay, voice options. So there are various voices. This is the first voice called Alloy. There are various options. If you visit the documentation, you would be in a position to see that. Let me see if there's a documentation here. Yes, there's a documentation. That would redirect us. Okay. It may take a few seconds for us to get to the documentation. And the documentation will give you just the different voices that you can try. The standard one, actually the default one, is the one that's Alloy, but they're different ones. So let's just explore just the different ones. There's Alloy, there's Echo, Fable, Onyx, Nova, and Shimmer. So you can choose any that works, and we would set the value over here. And not capital, it would be the same lowercase format that you used here. So let's run this. Let's listen.
Once upon a time, in a faraway land, there lived a young princess who dreamed of exploring the world.
So you can play around and play with the one that you feel like works best for you. All right, pause the video, then work on the challenge. We can also perform text-to-speech conversion with text that's in a foreign language, if English isn't your first language, or well, if it's your first language, but you can always use different foreign languages. I think, and these are the supported ones. not yet. We don't have any other languages yet to be supported at this particular point in time. So you can look at one of these ones and use such. So here I am going to give some text, which is in Spanish. Then I'm going to output it and, have it and read it out. So let's run this.
Había una vez, en un pequeño pueblo rodeado de montañas, un niño que soñaba con aventuras más allá de su hogar.
Okay, so if you want to learn Spanish, maybe that is something. But you'll also notice with the foreign languages, you'll notice it just sounds, it doesn't sound like a native speaker. It just sounds like someone who's maybe who has learned English for the first time, which, the model has been trained or optimized for English. I can say so because when from where I stay, I live in Kenya, in Nairobi, and the language that we normally speak is English. Yes, we speak English, but also we speak Swahili. But now when a foreigner comes and tries to speak in Swahili, you would tend to hear, their English still with their, with the tongue. So you could still hear the same case. You could still hear that English they're trying to speak. You can hear that they're not a native speaker, which is the case with this model. Like, for example, you might also hear, I'm not really conversant with Spanish, but with Swahili, which is the next one, if maybe you are from Kenya and you understand Swahili, you actually hear that this is a Mzungu. Mzungu is a white person, but this is a Mzungu's voice. So you'll be like, oh, okay, all right. So yeah, they can hear it. Let's listen in. Once it has done, let's listen in and you will hear something.
Hapo zamani za kale, katika kijiji kidogo kilichozungukwa na milima, kulikuwa na kijana aliyetamani kuwa na safari za ajabu mbali na nyumbani kwake.
So yeah, you might notice, but if maybe one of these languages, you speak one of these languages as a native speaker, you can try it out and you'll notice that distinction. This is Hindi. This is Hindi. So just remember just to write anything and you want in terms of the text, just to hear.
बहुत समय पहले की बात है, पहाड़ों से घिरे एक छोटे से गांव में एक बच्चा था जो अपने घर से दूर रोमांच की कल्पना करता था.
All right. At this particular point, pause the video and then work on the challenge. Audio quality. So we'll go through the last concept that for this particular workshop. So audio quality just refers to being able to get the high quality voice that you would want. Maybe voice that you can be able to use maybe in context where you might be, I don't know, maybe producing audio for high quality audio for big an audience that is quite I was trying to look for that word, that's quite keen with the audio. Maybe you're trying to produce a music, some sort of music, and people are really keen on specifics. Sometimes you may not be keen, but yeah. So you have two models. The one that we have been using is this standard, it's called standard TSS, standard text-to-speech model, and it delivers fast response times, but has some reduced audio quality as compared to now what is called the text-to-speech HD model. So you can always use any depending on the situation, but in most cases the text-to-speech model, the standard one, will just work fine. So I think I have two different, two similar texts, which again you could have a lot, but in many cases you wouldn't even notice a big difference. But you'll notice that. But the only thing, also something else that might be different is that for HD, the pricing is a bit different. It's a bit higher. I think per million tokens for the text-to-speech models, the million tokens words, almost words that you give to the model, should be about this particular point about $15. I'm not sure for the HD, but yeah, you can listen in and hear. Let's also do the same thing with this other one.
Once upon a time in a faraway land, there lived a young princess who dreamed of exploring the world.
That's the standard one. What about now the HD
Once
one?
upon a time in a faraway land, there lived a young princess who dreamed of exploring the world.
So I was just when you look at the documentation, they say that you might notice the difference if you're hearing, you have some headphones and you're listening to both types of audio, and yeah. So that's generally it with regards to this session. There was not much that we can cover about text to speech, how to interact with the model, but this is a basic way of just interacting with these models. And you can come up with just different sorts of applications. And as had mentioned earlier, maybe we should come up with some series, whether it's just short series on just building different applications for text to speech. Maybe it might give you some good ideas, and it might also help you to practice. So as part of the next steps, we would just advise that you work on projects in relation to text to speech. We will also, in the next, it should be in the next 2 weeks, we'll also be covering speech to text, just to also help you to see what potential these models have, these tools have. You might end up getting into a situation where you need maybe to develop such a tool that performs that kind of conversion, or you decide to come up with a startup that involves the same tool. So yeah, feel free to create such projects. All right, I hope you got to get some value from this workshop. And oh yeah, one more thing. Because we also covered just one particular set of models, just 2 models from OpenAI, you can consider the other different providers. So for maybe you could decide maybe to look at Google text to speech models, Amazon Poly, Microsoft Azure Cognitive Service text to speech models, etc. So you just look at whether you can also be able to use their APIs. Again, most of the times when you just learn one tool, it's usually basic enough, and it just helps you to just get to a solution that you want. But in some other situations, it just helps to just expand your knowledge on what's possible and what's not possible with one particular tool over the other. So yeah, so that's just also another next step, aside from just working on projects with regards to integrating OpenAI with your own applications. So yeah, so if you did love this experience and you felt like you got to get some valuable information, be sure to give this video a thumbs up. Again, we say that when you give our videos thumbs up, we just know that we're doing something good, and we just continue doing what we're doing. And if you'd want to be informed when we post such future videos, including the next one that's on speech to text, be sure to subscribe, and see you in the next course. Bye-bye.